Let's start with exact and non-exact problem. So that's what we'll be doing today. So over our meetings, we have been talking on about mostly integration by parts. Suppose you're given a problem this way. Let's say you're asked to solve 5x4 plus 3x squared y squared negative 2xy3 dx plus 2x3y negative 3x squared y squared negative 5y4, sorry, 5y4, the y equals 0. Now, if you're given this kind of problem, one of the things you will notice about this type of equation is that this is never a linear equation. This is a nonlinear equation. Okay, since we have it to be nonlinear equation, this simply means that we cannot use our integrating factor. You see that everything, so one of the things I will be doing in class or that I will be repeating over and over again is that I want it to stick into you. So whenever you have a linear equation, you know we cannot use what do you call it? There is no need to use Bernoulli because it's not linear, and because the problem we are trying to solve is linear. But once you see that the problem is non-linear, then the question arises: is it separable? Now, if we look at this problem, it is not separable, though it is linear, but it is not separable. So we cannot use separable approach or isolation. I think somebody was using isolation. Fine. Then the second thing now is this. Can I apply Bernoulli approach? Now, if you look at this problem, we cannot apply Bernoulli approach because there is no way we can express it in the form of y prime plus p of xy equals q of x, y, n. So there is no way we can do that here. Now, the next question arises. Since we cannot use separation of variable here, and also we cannot apply Bernoulli equation, but when you're given a problem, and the problem can be expressed this way, you can call this M, you can call this N, such that you can write this as M dx plus N dy equals to 0. So this one is called, this is where in this form we can apply the exact approach. So in this kind of case, what we need to test for is whether the equation we are given is exact or it is not exact. So looking at the problem we have here, let's rewrite. So this is our M and this is our N. Let me use a blue pen. Now, what is the first thing to look out for if you've decided that since I cannot apply separation of variable Bernoulli equation, now I'm to use a new method? What does it mean to be exact? It simply means, so let me write. What does it mean? What does it mean to be exact? What it simply means is that you are required to have your dm over dy to be equal to your dn over dx. Please understand that this is called partial derivative. Do you understand what I said? It's called what? Partial derivative. Is true, then the equation we are given is exact. So now let's start with the m dy. What is the m dy? The m dy is simply the partial derivative of this guy with 5x4 plus 3x squared y squared negative 2xy3, and this will give me what? What is it? Yes, 6x squared y minus 6x y squared. Yeah. Then dn dx is d dx. This is a 2x3y negative 3x squared y squared minus 5y4 equals 6x squared minus 6xy squared. Confirm this. This is correct. And so we could see thus the m, the y equals what? The n dx. So it means that the equation is exact. Very well. Now, we don't stop there. We need to be able to find f, right? So we need to be able to find our potential function, which is f. So how do we do that? So since we know that you, 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 were, you were told in class that um, your potential function is equals to what? The f is equals to since you can say m if you want. We can say this one is equals to what? The integral of what? So now, what do? We need to integrate with respect to x. When you integrate with respect to x, what do you have? X5, x3, y squared, minus x squared, y3, plus what? H of what? Of y. Thank you. Do you see that? So there is a, so this is called, the h of y is simply seen like a kind of, it's not really a constant, but it embodies functions of y. So when you see something like this, then you need to put into consideration that. So now, how do we go? The next thing we have to do is what? Now we differentiate with respect to y. So if you are starting with the integral of m dy, then the next thing is that you'll be differentiating with respect to x. Do you see? It works. So since it is exact, you can actually go both ways. Yes. So you don't need to say, when do I know I'm to use f equals to integral of m dx, and when I have to use f equals to integral of n dy. No, you can use them. Since it is exact, then you can use it, but make sure your integrations are correct. Once they are correct, you'll get the correct answer. So now we need to differentiate with respect to y. So if you differentiate this one with respect to y, this will give us what? This will give us, yes, 2x cubed y. Yes, y squared. Yes, h prime of y. So what do we do then? You compare it to what? To n. Yeah. Now we compare to n. Now compare to n. Do you see that? So this means that df dy equals n. This implies that I have 2x cubed y minus 3x squared y squared plus h prime of y equals to, what is our n? 2x cubed y minus 3x squared y squared minus 5y4. So when you compare, you discover that your h prime of y is the same thing as negative 5y4. What do we do here? We integrate. Don't forget that h prime of y, I can write it as dh dy equals negative 5y4. You see the kind of derivative I used there? It's a normal derivative, not the partial derivative. And I believe that you know why I'm doing that now. Yeah, because now we are just having just a single entity, y. So now this is the same thing as dh equals negative 5y4 dy. What do we do here to have h of y? What do we do from here? You integrate, exactly. You integrate. You integrate. So when we integrate, you will have your h of y to be negative y5, I think, y5, right? Plus what? Plus c. So this simply means that our f here is simply equal to f of x comma y is simply equal to x5 plus x3 y squared minus x squared y3 negative y5 plus c. So this is the final answer. Yeah. So this means that your general solution will simply be x5 plus x3 y squared minus s squared y3, right, minus y5 equals to c, small c. You see? So when you take f negative c, you get a smaller c. So this is the final solution.